Good morning, everyone. Welcome to join our Autel ADAS product training today. Today we will go through the whole process, how to calibrate the ADAS system, such as the lane departure warning, the radar system, as well as the blind spot and light vision. Please let me introduce our trainer who came from the Autel US head office, Mr. Winnie.
Hello,
Welcome,
everyone.
Ms. Winnie.
Thank you so much for having me today. Everyone, thanks for coming. Today, we're going to go over the basics for ADAS, as well as how to service these systems. Now, I see we got a couple of people still making their way in, but for now, we're just going to go through some basics. We have all encountered ADAS one way or the other, yes. Maybe we own a vehicle with ADAS, maybe we've worked on one. Whatever the case may be, we want to know how to identify these systems, how they work, and of course how to fix them. So who here knows what ADAS actually stands for? There we go, thank you. We have active ADAS systems and passive ADAS systems. So the difference between the two, just like the names suggest, the active ADAS systems actively correct the vehicle's speed or direction to maintain the vehicle safety. Passive systems offer the same type of functions, but instead of correcting the vehicle, they provide warnings or some kind of message to the driver, and then it's up to the driver to make those corrections manually. So those are the basic types. There are different ways to determine if our car has ADAS. We can look for a variety of sensors located throughout the car. This one, for example, has about 4 different systems just by looking at it. From the front, I can see a camera in the windshield. I can see a camera here in the grille. I know that there are cameras under the side view mirrors. There's also a radar sensor down here in the bumper. So just quick looking at the car, I can tell this has front-facing camera, or what we call lane departure, which maintains the car's direction or the distance in between lanes. We have our radar sensor up front that controls the speed of the vehicle. And then, of course, the cameras all the way around is what we call the 360 or around view monitoring system. We use this when the car is in reverse or going to be parked. So today, we're going to go through how to calibrate one of these systems, the lane departure warning system, more specifically. These systems have 2 different types of calibration. We have a static calibration and a dynamic calibration. The static calibration, just like the name suggests, the vehicle will remain stationary inside of the shop, and we are going to set up a variety of targets or calibration equipment around the vehicle at very specific locations in order to perform the calibration. Dynamic calibrations are done on the road. The vehicle is being driven while the camera or sensor is in its learn mode, where the sensor is actively collecting information and using that to calibrate itself. So today, with the Autel tool, we're going to go through the entire procedure, how to perform a pre-scan and post-scan as well, so that we can document these repairs, so that we can present them to insurance companies or vehicle owners for proper payment. So getting started with the tool, it's a Samsung tablet with apps on it. One of these so-called apps is the Maxisys diagnostic software. So with this software, not only can we calibrate all these different types of vehicles, but the tablet is a fully capable diagnostic tablet. So not only ADAS calibrations, we can do check engine light, clearing and reading, oil life resets, electronic parking brake resets, anything that's related to the diagnostics as well as ADAS. But for now, let's go through selecting and scanning this vehicle. We'll go to Infinity. First question we get asked is if we want to associate a repair order number with this car. We'll start with automatic selection, and we're going to have the tool read the VIN, tell us what kind of car we're working on. Pulls up the VIN, wonderful. and that's our car, 2014 Infiniti, which is right behind us. So on this main screen, we'll see a couple of different options. If we wanted to diagnose the vehicle, so like I said, check engine lights, electronic parking brake systems, transmission, whatever the case may be, we can go through this menu. But for our recording purposes, we want to select the pre-scan option. This is actually going to perform a full diagnostic scan, as well as save the scan to the RO number that we have entered prior. So while we wait for this scan tool to go through all the different systems on the car, just want to go over a couple of things on the system itself. This is going to be the calibration frame that comes with the complete solution. This frame can not only calibrate forward-facing cameras, but it can handle front-facing radars, blind spot, night vision, 360, rear collision warning, pretty much the entire vehicle, whatever the system may be. So this frame is completely adjustable in terms of angle, side-to-side position, and height, so that the targets can be placed very easily. We won't have to make as many adjustments to the frame as you would normally need to do with other solutions, or the OEM solution for that matter. So with this, along with our variety of targets, we're going to be able to set up and calibrate pretty much any vehicle. When we go through these targets, we'll see not every manufacturer has a target. Like we said before, some manufacturers have what's called a dynamic calibration. So those cars that get driven on the road, for example, Fords, Jeeps, other Chrysler products, Volvo, these are the kind of cars that are driven on the road to calibrate. Therefore, you're not going to find a target for those specific brands. Going back to the tool, it's going to ask us if we would like to attach any photos. It's a good idea to take a photo of whatever kind of repair we're doing. So let's say it's a windshield we're replacing. I like to take a photo of the broken windshield because there's no code or message in the car that says you have a cracked windshield, please perform a calibration. So we want to document this to the insurance companies as another form of, again, documentation indicating what we've done, the repairs that we've made. So I'm going to select yes. With the plus sign, I can take a photo and take a photo of everyone. Say cheese. There we go. Okay, check mark. And now that photo is on our report for the insurance, the customer, whoever would like to review it. We can add up to 5 photos. So in the body shop situation, we can take pictures of underlying wiring damage, brackets, things that are not visible from the outside of the vehicle. On the report, you'll see a number of different systems. This car has 18 of them. You'll notice there's a couple of faults, and we can look at those in a moment. But what's more important is the blue icon that you see on the right-hand side. It says ADAS. This little indicator shows us that this system is indeed an ADAS system and may or may not have a calibration. When I say it may not have a calibration, again, not all these systems require a calibration requiring a target or an electronic piece of equipment. Some of them are low-speed systems. For example, Parktronics or your Park Assist systems, the small round sensors that you'll find throughout the bumper. Those are just physical sensors where you place them, connect them properly, and they're ready to use. There's no preset calibration for them. Other systems, like the front-facing camera and radar, are systems that we use during the vehicle's movement. High speeds, has to be a little bit more accurate to properly slow down the vehicle. Those are the systems that we're going to be calibrating. So I've made my pre-scan. It's already saved to the tool under that RO number that I've selected. At this point, I want to exit my tool and perform my physical repairs, whatever they may be. An alignment, windshield replacement, body panel replacement. I could be doing something as general as replacing the radiator on this car. In order to access my radiator, I got to remove my front bumper, I have to remove the grille, maybe headlights are in the way. Anything that would involve the movement of one of these ADAS sensors would warrant a calibration. So even though we might not have codes for that sensor or that system, we need to be aware of the physical repairs that we're doing. because those are what's going to dictate whether we're calibrating or not. So once I've made my repairs, I want to go back into the scan tool on the post side of the scan to perform the calibration itself, as well as document that with the post report. So Demo 4 is the name of my RO. This is all my vehicle information. It's not complete yet. We'll get to that in a moment. What we want to do is select the blue diagnostics icon at the top, and this will reload the menus. We won't have to rescan the vehicle or re-enter the VIN. Everything is already preloaded. So we'll see a similar screen than we did before. However, now it's going to say post-scan. This is going to be the option we use once we're done with the calibration or any kind of resets that need to be done. Okay, so we go into ADAS Calibrate, and the tool automatically starts scanning the vehicle for all of the present ADAS systems. These are going to be all the systems that we saw prior with the blue icon to the right-hand side. The tool is going to scan all of those systems and present them to us with any available calibration procedures. Okay. So this car has what we consider 6 ADAS systems, but only the first 2 actually have calibrations associated to them. You can tell this by the bullseye symbol all the way on the right-hand side. You'll notice, for example, adaptive light does not have that icon all the way on the right-hand side, whereas lane camera does. Lane camera, of course, referring to the front-facing camera that we find behind the windshield. Once we select that system, the tool will display all the reasons a calibration would be necessary. So for this specific one, unlike others, it doesn't directly state that a windshield replacement is cause for a calibration. However, in a typical windshield replacement, the camera does have to be unhooked from the bracket and then reinstalled on the new windshields. That simple movement of the camera is grounds for calibration. It doesn't matter if the camera remains plugged in the entire time. It doesn't matter if the ignition stays off the entire time. It's all about the physical movements and repairs that we're doing. So as soon as that camera moves, or that sensor in relation to a radar, we have to recalibrate. So let's say during the windshield replacement on this vehicle, I have to remove the camera for whatever reason. The tool will then give us a list of materials that we need to prepare for the specific calibration. The calibration frame, 600, is this main structure right here, red frame with the aluminum crossbar. The target board, 601, 06, left and right are going to be the 2 targets that we're going to use for this car. My assistant's actually going to pull them out for me right now. And they are already mounted to the target board holder. That's the 600-02. So as you can see, it just simply slides in to the openings on the crossbar. We will also need the wheel clamps, lasers, which are on the rear wheels already on this vehicle. I'll show you guys how those work. And then the tape measures, which are also attached on the crossbar. Our first step is to tell the tool whether we're working on the ground or on an alignment rack. The tool does allow us to work on an alignment rack so that we don't have to double up on shop space in order to perform these calibrations. In case you guys were wondering, typical calibrations can require anywhere from 3 meters in front of the vehicle to 10 meters in front of the vehicle. So if for some reason we don't have that space in front of our alignment rack, there's nothing wrong with turning the vehicle around 180 degrees and putting the frame on the back end of the alignment rack and calibrating it that way. For today, of course, we're going to be working on the ground, so we'll select A. The tool will then give us all of the preparations or the prerequisites for the calibration. So it's going to tell us to park the car on a flat level surface. It's going to give us a space requirement for this vehicle, which is 5 by 3 meters in front. It indicates that all of the fluids should be full: oil, washer fluid, coolant, fuel. All of these things affect the weight or the suspension of the vehicle and therefore the angle of these sensors. And we'll go into a little detail on that in a moment. It's going to ask us to make sure that the tire pressures are correct. Again, this is going to affect the angle of the car and interfere with calibrations if they're not properly inflated. It's going to warn us about reflections. These calibrations are sensitive to light. This doesn't mean that we cannot do them, for example, outside. I have done them outside, but again, no direct forms of light. So if there's any glare, we will want to reposition the car or maybe place a cover over the car so that we can block that incoming light. Once all of these prerequisites have been met, we will then start with the setup procedure. So on the bottom, you'll see that there are 4 buttons. The video is just the generic video going over the basic parts and functions of the frame. The setup button is going to give us those step-by-step instructions that we want to go through each time we're setting up this frame. The OK button is actually going to start the calibration for us. So until we've actually set up the frame, we want to avoid hitting that OK button. Exit, of course, will bring us back. So let's go to setup. Our first step will be to zero out the frame. This is what I call the pitch of the crossbar. So this changes the angle of the crossbar so that the targets can be placed perfectly perpendicular to the center line. So there's a mark over here on my left. Once this is aligned, we're then going to move to the front and make sure that the lateral position of the crossbar is centered. There's an indicator over here, so we're going to line that up and lock it. And then this piece, which we call the sliding laser plate, which moves left and right depending on where the radar sensors are located. This is what helps us calibrate those. We're also going to set this to the middle. The next page instructs us to turn on the center laser, which is found on the sliding laser plate. And we're then going to move the frame towards the front of the vehicle. At this point, it's not a bad idea to adjust the height of the crossbar so that it is easy for us to find the center of the vehicle. I'm actually going to lower it down to about the center of the bumper to assist me with placing it. There is, of course, a motor, so we can do this electronically for faster movement, but again, the manual crank is more precise. So can everyone see this laser over here? It's underneath the license plate. So now that the frame is in front of the car, our next step is to set the distance. But what we want to do is set the distance from a specified point on the car to the crossbar. So what I'm doing right now is setting my distance according to my scan tool, 384 centimeters. Do this on both sides of the vehicle. So my helpers are holding the tape measures, and I'm going to move my frame so that we have that distance between the crossbar and the wheels, the front wheels, and at the same time maintaining the center point with my laser. Okay, so now my distances are set. I'm just going to double check to make sure that they haven't moved. And my mark is still on the center here. So now my distance is set. At this point, it's a good idea to simply lock down the frame so it doesn't move on us. We don't want to go too hard because we will end up leveling the frame off in a little bit. So that's just to keep it from moving. Our next page asks us if we are using the Autel wheel clamps that came with the set, or if we are pairing this frame up with our alignment rack. There are many alignment racks out there that offer attachments for this frame, where there are sensors that attach to the ends of the crossbar, and they utilize the alignment machine's rear targets so that we can place the frame at the correct distance and angle all in one movement. We also have the tower or the alignment screen that gives us the graphic with the arrow that moves left to right as we are moving the frame and getting closer to the specified value. Today, of course, we're going to be using the wheel clamps. So I'm going to make my way back there and show you guys how these work. So this is the Autel wheel clamp, standard wheel clamp. These fingers, as I call them, can be removed and adjusted for different size rims. They can go up to 24 inches, so even if you have to do a calibration on a pickup truck with aftermarket wheels, nothing to worry about. So with these wheel clamps, what we want to do is attach them to the rear wheels and tighten them so that they are secure on the rim. At the same time, we want to make sure that the fingers are in full contact with the face of the rim. Otherwise, our clamp is going to be sitting at an angle, and it's not going to be very easy for us to center in the next step. Once we have it attached, we're going to turn on our laser and point it at the red ruler towards the front on the crossbar. Once we have our lasers shining on the rulers here on the crossbar, now there's no specific number that we're looking for. The key here is to have both values equal. We're going to go here to the middle, and we're going to actually move the crossbar left or right so that the value on both sides is the same. This is 150, this is showing about 170. So right now, both of my lasers, same value. I'm between the 160 and 165 mark on both sides. This tells me that my crossbar is now completely centered to the rear drive line of the vehicle, or the center line. And we will open up these mirrors. What these mirrors are going to do is reflect our laser beams back to the rear of the vehicle. So it's pointed in quite a bit. What's happening right now is the reflections, when they're hitting the mirrors, are getting reflected, but the angle is not correct. So it's going off towards the passenger side of the vehicle. At this point, we're going to make an adjustment to the pitch or the angle of the crossbar. And as I make this adjustment, the laser is going to move left and right. For demonstration today, what I'm going to do is I'm going to split the difference, which is essentially what we want to do. We want to keep the value the same on both sides because we're trying to calibrate to the drive line of the vehicle. If the suspension is off, that car is tracking down the road to one side or the other. And if we calibrate the camera not in line with that, our camera is going to be looking one way and our car is going to be driving the other. And the driver is going to complain that the car is constantly pulling him back towards the center or towards one side or the other. So these are all things to realize when we're doing these calibrations. Our calibration frame is ready to go. So that was the whole setup. It's going to bring us back to this preparations screen. So like I said before, once we go through setup, we're going to go to OK to actually perform the calibration. It's going to give us a reminder to make sure that the calibration frame is properly been placed. And it's then going to give us the positions for the targets. The car requires 2 targets, and unlike most, this requires the targets to be offset. So this one will be centered, and this one has a distance of 600 millimeters. In most cases, these targets are equally spaced on both sides, and the camera calibrates its left and right limits using these targets. Each car is a little different though, and the tool will always explain where to place the targets. This one, however, like we said, calibrates the center point and then one limit. It then, of course, tells us which targets to use. We have already attached them, the 60106 left and right. Left, of course, referring to the vehicle left or the driver's side. So let's make sure not to invert them because unlike these, some of them cannot be swapped out. This one, for example, is a different Nissan Infiniti. If we go like this, the patterns change and cannot be done. So this would actually give you a problem if you were to swap these over on a different vehicle. So just pay attention to the direction if you're working with 2 targets. The targets themselves are magnetically attached. So there's a safety strap here. So just in case we knock into the targets, they won't hit the floor and break. They attach easily using magnets. The tool is going to ask us to check the level. The level is here, indicated by 2 bubble levels, left, right, back and forth. Back and forth looks good. Left and right could use a little bit of an adjustment. When we're looking at these levels, the way I like to adjust them is by looking where the bubble is and going opposite the bubble. So for this case, I'm going to work on this side, opposite the bubble, and I'm going to tighten these screws down equally so that I don't disturb the forward and backwards level. I only want to adjust left and right. Perfect. Next step is the height. So there is a ruler built into the back of the frame. We're going to release it, make sure it touches the ground so that we can accurately measure the height off the ground. And we're going to set the height to whatever distance the tool indicates. This one is 1450 on the B side of the ruler. There are two sides. The B relates to lane departure warning targets, anything that uses this kind of support, or the bigger one that looks like this. The A side, we'll see it when we're doing a radar calibration, how we measure the height of the crossbar. So like I said before, I'll use the motor to get me into the general area and then use the manual crank to dial it in precisely. Make sure the ignition is on. It reminds us to check the ignition because on these cars with push button, they like to time out. So the calibration is successful. As you can see, all we got to do is set up everything precisely. Our conditions are acceptable and the calibration will go through. Again, these calibrations are not done in the tool, it's done in the car. The car is actually calibrating the camera on board the vehicle. The only thing that our scan tool is doing is telling that camera to start the relearn procedure or start the aiming procedure. Once we do that, it's all up to our setup and our environment, of course the car as well, to visualize these targets and memorize this distance so that it can use it while it's moving on the road. So that was the entire calibration for that lane departure warning camera in the windshield. At this point, I like to take a screenshot of this screen because not only does it give me my successful message, but it also tells me the car that I'm working on and the RO number in the lower left-hand corner. Okay, so back to this screen, pass no fault on my lane camera system, wonderful. So I'm going to go back and perform my post scan. So now it's going to go through all the different systems once again, and the tool is going to do a comparison before and after, before we calibrated and afterwards, just to make sure that there are no new codes. All of the codes that you see right now were pre-existing problems. So if a customer comes to us, for example, for a windshield, we're not going to go worry about their 420 code for a catalytic converter. That's something that they got to take care of on their own. If the shop leaves with that problem, it's very obvious why. We're not replacing the catalytic converter. We're doing a windshield replacement. So what we're trying to do is document what we've done and prove that the vehicle is not leaving our shop with any more problems that it came in with. It should leave in the exact same condition that it came in. So on the post test, do I want to attach photos? Yes. I'm going to choose a photo this time, and I'm going to go into my gallery, and I'm going to attach that screenshot that I just took of the calibration being successful with all of the specs. All right, done. So now my post scan is complete. What I want to do is exit, and I'll come back out to this screen right here. Now I can switch between all, which will allow me to select my vehicle, and history, so that I can go into, of course, the history of the scan tool. I want to look at that last RO that we just did, the infinity. We'll go up to this arrow at the top, and we'll click View PDF. We can actually preview our pre- and post-scan right on the tool. So here's our pre-scan report. All of the different systems, all of the ADAS icons, as well as all of the codes that were present on the vehicle when we started working. As you can see, most of them are past codes, meaning that they happened in the history of the vehicle or sometime in the past, and currently it's not a problem. The few codes that you see with the CRNT, or current, those are active codes, things that are happening at this very moment. So on this car, looking really quick, I see 4 codes: front left, front right, right rear, left rear, or rear left. Those, for me, indicate the TPMS sensors, the sensors inside of the wheels. I did notice that this car has aftermarket wheels. It may not have sensors inside those wheels. So when we're going through the preparation, we'll have to manually check those pressures rather than relying on our dash to tell us what the pressures are of those wheels or anything, or any kind of electronic scan tool. There's no sensors for us to communicate with. Everything else, being a passcode, is not going to stop us from performing our calibration. On the post report, everything is passed. I do see one more current code under the BSW buzzer power supply circuit. During or while working on the car, the batteries do tend to die because we are working on them for an extended period of time. This code simply refers to a loss of power. So the battery went dead and one of the systems stopped communicating. Nothing wrong with that. We can clear that code once we make sure that the car starts. At the very bottom, it will show us the reasons for calibration. So like we said today, we removed the camera, we had to reinstall it. That's a reason for calibration. It will also then give us our values, or the calibration parameters of acceptable values and our actual measured value, along with any photos that we attach. So when we're going through this, it's a good thing to know about the different systems and how they intercommunicate. Okay, so there are sensors in this ABS system that also feed information to, let's say, the radar system or the automatic emergency braking system on our car. So if our car, let's say, is involved in some kind of accident or just needs a general repair, one of the wheel speed sensors is out, the vehicle cannot determine how fast that vehicle is moving. If there is an ABS problem and the car can't determine how fast it's moving, systems like automatic emergency braking become disabled. Not because there's a problem with the radar system, but there's a problem with a primary system that our ADAS system is depending on for information. So if we don't fix that ABS sensor, our ADAS system is not going to be operational. So even though we may be able to calibrate that sensor so that it's looking in the right place, the angle is correct, our car is not going to be able to utilize that system until we fix everything else. So it's important for our customers to realize that even though we're doing one thing, it may be affected by other problems that might be present on the vehicle. Another example, for lane departure warning, if the car has had any kind of power steering repairs, or if it's in a collision and it has the power steering rack completely replaced, or we do an alignment at the very least, we have to do a steering angle sensor reset. That steering angle sensor tells the car when the steering wheel is pointed straight forward, right, 0 degrees. Our lane departure warning system, what it does is it monitors our lanes and corrects our steering, depending on how far we're drifting, left or right. If our steering angle sensor is not set properly or hasn't been set at all after a major repair, our car will not know how far to correct the steering wheel, and it's either going to over or under correct, and that can lead to more dangerous conditions than what we were trying to avoid. So again, it's very important for us to know how these systems are interconnecting and to realize that even though we're calibrating, that doesn't mean that the system is going to start working right after that. In most cases, if that's the only repair, yes. But if there is other codes like this car, it would be wise to look into it and make sure that there's nothing that's going to affect our ADAS system, whatever it's going to be. So I already know what all these codes are, so I'm going to go through a quick erase. So this is going to go through all the codes, erase them, and as long as they are not active codes or current codes, they should disappear from our scan. And again, once we cycle the key and start the vehicle, all of these should no longer be there. Now, if we do find a code for a system that we think is going to affect our ADAS system, please do not clear those codes. Once we clear those codes, not only are we responsible for the repairs that may be related to those codes, but in case we do clear those codes and we give the driver a false sense of security with our ADAS system calibration, they might end up in danger because that system is not going to operate correctly. So again, those codes that I've cleared are history codes, not related to anything that I'm going to be doing or have done on this car. Things like ABS, steering angle sensor, if it's an active code, take care of that problem first. Then come back and do the calibration. So now that I've started the car, I'm simply going to rescan the system with the ignition switch on and the engine running. Now all the systems can cycle through all of the circuits, make sure that they're all operating properly, all the sensors are giving their correct signal. If I see any fault codes after this point, I'm going to have to look into it and make sure that there are no current codes. Perfect. So, similarly to how we set up the lane departure warning setup, we're going to start with the frame in front of the vehicle. We're going to set it at a specific distance. Again, to do that, we're going to use the tape measures, pull them out, set our distance, move our frame accordingly. Once we have our distance, it's always going to be with the wheel clamps next. We're going to use those to center and square the frame so that this piece ends up directly in the center of the vehicle's driveline. Now, the only difference between lane departure and radar calibrations is the type of target that we're using. Lane departure, or a camera-based system like lane departure, I should say, is going to use a visual target, some kind of geometric pattern with different shades, black and white. Radars use some kind of electronic equipment or some kind of electronic reflector that will take the radio waves emitted by that radar sensor and bounce it back at a certain speed, angle, whatever the case may be, depending on the radar sensor itself. For this one, for example, it has a radar in about the same location, right under the headlight on the side of the bumper. And again, the height is not going to be something that our tool is going to specify. The height is going to be built in to the height of the radar sensor. So we're going to set our height to the center of the radar sensor, and then similarly we're going to move this over left or right depending on which side we're working on. Next, we're going to level this piece. It's important that we make sure that this is level because this is what the radar is going to be using to memorize its angles. So this one, opposite the bubble, I'm going to go on this side, and then from the front. So now once we have it level, the scan tool is going to initiate the calibration. For most radars, it's a three-step calibration. So looking closely at this piece, we'll see a knob here with numbers. Position 1, as you can guess, would be the first position. This puts the reflector at a 3-degree angle, pointing down. This is normally the position that the radar uses for short-range calibration. So our radars usually detect long-range, mid-range, short-range. The short-range distance is when the automatic emergency braking usually kicks in, starts to slow down our vehicle so we don't hit the person in front of us. 2 is going to be straight up and down. This is going to be for cruise control and maintaining our speed and distance to the vehicle in front. Position 3 is the long-range calibration. So again, the radar is going to be looking up forward ahead just to identify vehicles and potential obstacles that can cross in front of us. So after each position, the tool will indicate start on position 1, hit OK when you're ready. It'll calibrate position 1. It'll then ask you please select position 2 and press OK when you're ready. And again for position 3. So radar calibrations, when it comes to the setup procedure, placing the frame is pretty much always going to be that procedure. Put the frame, set your distance. With the wheel clamps, we're going to center it and square it. And then depending on the system we're working on from there, it's going to vary. Either we're going to use a visual target for a camera-based system or some kind of electronic equipment or reflector for our radar-based systems. So I've put in an RO number, and I'm going through the same thing that we started with last time. We're going to be scanning the vehicle and doing our pre-scan before we start any work. The MA600 is our mobile Ldw calibration solution. So like our complete solution, it offers complete adjustability so that we can calibrate pretty much any vehicle when it comes to lane departure warning. It comes with a variety of targets, just like our complete set, as well as all of these accessories that we're going to be using today to center this frame. As you can see, this frame is a lot smaller than our other one. It is even, can be disassembled into 3 small pieces so that you can easily transport it in the back of your car. So you have your main post, your crossbar, and your base at the bottom. So those 3 pieces are going to make up the MA600. So now I can start my calibration procedure. It's important to know that in the pre-scan, we will not be allowed to perform calibrations. And that's not because the tool can't do it, but it's trying to protect us as users from performing a calibration in the pre-scan section. If we do that, our tool is not going to record the results of our calibration, as well as any kind of change that happens between our repair and our calibration. So if any codes are removed because we complete a calibration, it will not be displayed in the pre-scan. We got to make sure that we're in the post-scan section to do these ADAS calibrations. So again, it's going to start scanning all those ADAS systems. So like I was saying, the MA600, it is mobile, but it only covers, for now, the Ldw calibration features. If we want to expand it to, let's say, some radar or some 360 camera calibrations, there will have to be expansion packs added to the frame to increase its capabilities. As it comes, the MA600, again, only front-facing camera calibrations. So we're going to go through the lane camera calibration. Again, on this vehicle, it's going to use very similar numbers, the same targets, as we could imagine, but the setup procedure is going to be a little different between the two. As you may have noticed, the frame, MA600, does not have the same lateral capabilities with the crossbar that our standard frame does. This one, therefore, does not use wheel clamps for centering. We're going to use the old school plumb bob and center line. I'm going to show you guys a couple of tricks to make that as easy as possible, but for the MA600, in order to make it portable, some of the other pieces had to be slimmed down. So no wheel clamps, no motor to bring it up and down, everything's going to be manual. The material list for the MA600 calibrations is usually a little longer than our standard frame because of all these small accessories that we need to use. Okay, calibration frame 1500. That's the MA600 frame itself, that's the part number. The target board 60106, left and right, are the same 2 that we used before. We're going to go get those again. The L-shaped bracket is this piece right here. We're going to use this to measure our distance from the front wheel. The 2-line laser is here. We use this for positioning the frame. Our 5-line laser comes in this little case and enables us to have 4 lines all at the same time. The reflective board, or the reflector as I like to call it, the small black piece with the green strip, and then the assisted reflector, I like to call it the mirror. This is going to help us look under the vehicle so we're not on our knees the entire time. Our plumb bob comes in the kit as well. Chalk, tape measure. The tape measure, I'm actually going to borrow it off of the complete solution, but you will need to get yourself a metric tape measure. It's very important that we get it with the metric division so that it is as accurate as possible. And we will need tape today to mark all these points on the ground. So just like the complete frame, are we working on the ground or are we working on an alignment rack? The MA600 is very difficult to utilize with an alignment rack because of the need to go underneath the car and get our center line. With the alignment rack components, sometimes it can be a little difficult. It is doable, but again, it's going to take us a little bit more time. For today though, we are on the floor, and just like before, we're going to have all these preparation screens, all these preparation requirements. Before we go into the actual calibration, we're going to select the setup button to go through all the setup steps. The first step, which is going to be very typical for the MA600, will be to use the plumb bob on the front and rear of the vehicle so that we can transfer the center points down to the ground. I'm lifting up the hood because this hood, unfortunately, is not magnetic. It's made out of aluminum. We will place our plumb bob here at the center. Make sure that it's not hanging up on anything. So that's one. That's going to be my center point. And in the back. Our next step is going to utilize the reflector and our 5-line laser. This piece has a line at the bottom. We're going to line this piece up with our mark right here at the front. So we're then going to take our 5-line laser and the mirror and bring it to the back of the vehicle. We're going to turn on our laser and place it so that the laser point on the bottom, and make sure that the laser itself is level. It has a bullseye level at the top, and we can adjust this. So now that it's level, we're going to use our mirror. We're going to try to find that reflector at the front of the vehicle. And we're going to make adjustments to our laser. If we scooch down, we look into the mirror, we'll be able to see the reflector at the front of the car. If we use the white knob right here, we can see the reflector go from bright to dark and then bright again. That's the laser hitting that center reflective strip and indicating that our laser is now on the center line of the vehicle. So we all agree that now that laser is on our center line. So what we're going to do next is take our reflector and move it back. We're going to use this to help us find that center line again. You can see it on my hand right now, but that's nice and clear. And at the same time, we're going to be measuring from our front plumb bob dot distance of 1 meter. Thank you. Okay, so we're going to move this up. Okay, so I have my mark, 100 centimeters or 1 meter. Just like we did in the back, we're going to put that center dot on our plumb bob, and we're going to level off our laser. Our reflector now can go here to help us, and everyone should be able to see what we were doing before pretty much underneath the car. What we can do now with our 5-line laser is turn on the 5 lines, and it's going to indicate to us that we want to measure points C and D in this picture are 1 meter left and right along those perpendicular lines. So that's why the 5-line laser is extremely useful, and for this reason also necessary for the MA600. Like we were saying before, the MA600 has a lot more setup steps because of its portability. We need to do all of this preparation so that the frame can properly be placed without the need for wheel clamps, like the complete system. Okay. So now I'm at 100. Mark my line. Okay. Got my point there. So the L bracket right here is going to assist us in measuring from the front wheel. So this, very simply, gets placed against our front wheel so that it is in line with the hubcap. I'll take this. So the laser is going to be on the center of the front wheel, and the bracket, we're going to overlap it with that center mark, because this bracket is going to help us measure distance. So now we're going to take our 5-line laser and move it again. I'm going to connect it from this one to this one. This is going to make our perpendicular line over here parallel to our center line. So what we're doing is pretty much offsetting our center line over to the side of the vehicle. Once we have this line marked out, along this line is where we measure our distance. The reason why we go through all this trouble is because when we're measuring our distance, if we're not perfectly straight, if let's say we're off at an angle, that measurement actually becomes longer than it should be. So if I'm straight here at 1 meter, at an angle I might be 1.1 meter, and that's off by 10 centimeters. Obviously that's a big difference. So again, the MA600, a lot more setup in order to place it properly, but once we have all these points on the ground, it's one step from this to calibration. Four vertical lines displaying. We're going to connect to our center point over here, and our point over here should be in line. I'm going to come over here and mark my distance. Again, the distance is 3850 millimeters or 385 centimeters. So now, I've re-established my center line using my 2 points, or I should say 3, 1, the 2, and 3, the plumb bob dot in the front. So now I know that this frame is perfectly perpendicular to my vehicle's center line. This is what we would have done on the standard or the complete solution with the wheel clamps and the mirrors, opening them up and adjusting the angle. So all of this is done through the use of points and laser lines. What I'm doing right now is just stopping the frame so it doesn't move on us. Okay, so this instruction that we see here is the part that I was mentioning is a little difficult when we take our 5-line laser and move it pretty much to this point right here. So like I said, I suggest we use our 2-line laser and we connect the dots manually. So again, this is everything that we've done up until this point. We've connected our points along our center line, and our calibration frame has been placed properly. So once we have that set, we can open up the arms. And again, do this with ease. You don't want to move the frame after you've gone through all the work of placing it. On this one, like we said before, it is slightly different in that the targets are offset. So the driver's side target goes at a distance of 600, and the other target actually goes in the center. So in order to utilize, or in order to hang that center target, we need to utilize this hanger right here. So we're going to remove our 2-line laser. These are directional. We want to make sure we get the right one. And these magnets hold our targets in the correct place. Okay. Okay, it's going to ask us to level off the frame. So this one, the back and forward look good. The left and right need a little bit. So I'm going to go over to this side and just adjust. Okay. Perfect. The height is 1450, just like the other one. So this one uses a digital height measuring device or digital tape measure. So it allows us to read the height in motion. So right now it's actually changing from 1340 up to 1350 up until my 1450 value. Like we said before, this one doesn't have a motor, so it's all manual crank. 1450, perfect. Okay, we're at 1450. Everyone ready? So now it's going to communicate to the vehicle, start the calibration procedure, and as long as everything's okay, I know we got a couple of lights off, we'll see if the calibration, if the conditions are acceptable. So our calibration is in progress and has been normally completed. So again, this is the entire procedure. Most of it is setup. The calibration itself is 30 seconds of clicking buttons. The calibration itself isn't the hard part. It's the setup and making sure that our placement is as precise as possible. So again, we want to take a screenshot of this for our documentation purposes. We're going to escape back out and perform a post scan once the repairs are done.